Alright, sorry about the little jump there. Alright, let's see, where did we get off to? So we were just looking at expanding out our two brackets here. So continuing that, we got 7x squared minus 7x minus 7 plus 7. And then from there, we're just going to look for our like terms. So we've got a couple of x squared terms, so 3x squared and 7x squared to get 10x squared. And then if we're adding all of our x terms, we get negative 27x. And then adding our constants, we get negative 3. So now it's just up to us to compare these two. The question was asking, are these two things equivalent? So did these two answers give us the same thing? Well, clearly no, our x squared term is off, even though everything else matches. So to finish off this question, we just want to include a little therefore statement. Therefore, they are not equivalent. Okay, let's try a word problem now. So we've got a rectangle and we're given its length and width. And we've got a triangle, we're also given its length and width. So if it helps you draw a little sketch, you have an idea of what you're looking at here. You might have wanted to switch your length and width. Ultimately, it really doesn't matter. For our triangle, our base is usually going to be across the bottom, and then our height is coming up at a right angle. So we want to just create our equation here. So area is going to be length times width. So we're just multiplying these two binomials. So we can multiply everything out. So 2x times 6x is giving us 12x squared. 2x times 2 gives us 4x. 6 and 6x gives us 36x. And then our constants give us 12. So once that's totally simplified, 12x squared plus 40x plus 12. So let's try a triangle now. We've drawn it out, our base and our height. So your area for a triangle is half of your base times height, or your base times height divided by 2. I think this way is going to be a little bit easier for us. So let's keep going in this way. So our base, 6 plus 8x, and our height, 4 plus 3x. Now it's up to you when you want to multiply in this half. You can do it now or you can do it later. I think I'll go now. So half times 6 is 3. Half times 8x is giving me 4x. And you're only picking one place or one bracket for this to distribute to. Okay, so that's where we got to. Now let's just expand. 3 times 4, 12. 3 times 3x, 4x times 4, and then finally 4x times 3x. Now it's up to you for the order you want to leave this in. Proper mathematical form is going to have our x squareds first and then going down that way. So let's try that. Let's put our x squared term first. We've got 12x squared. We can add our x's, so we're going to get plus 25x. And then our constant just goes at the end. So same as last time, from this point we can compare. The 12x's are good, the constant term's good, but our middle term doesn't match up. So no, the areas are not equivalent. So we can just squish that in there or put a little box around it, just to make it stand out a little bit. Great. All right, let's try another application here. This time we're looking at volume, so 3 dimensions. So we've got these two rectangular boxes, and same type of question, are their volumes equivalent? So let's go our box 1. So our length is x minus 1, our width is x minus 3, and our height is 2x plus 6. Okay, so pretty much same as area. For volume, we're just going to multiply all these things together. So volume equals length times width times height. So x minus 1 times x minus 3 times 2x plus 6. And it's up to you to decide which order you want to start multiplying things in. I usually prefer to go from the left-hand side. So let's multiply that out. Simplify, and then we're going to be good to multiply to the next bracket. So x times x is x squared. X times negative 3 is negative 3x. I'm just going to skip a little step here. I know that this gives me negative 3x, and this gives me another negative x, so together that makes negative 4x. And then I multiply my constants to get positive 3. Okay, and then we're left with multiplying our 2x plus 6 on our next step. So let's go through and do that one now. X squared times 2x, 2x cubed. X squared times 6 plus 6x squared. Now we're on the negative 4x times 2, negative 8x squared. Negative 4x times 6, negative 24x. And then our 3 gets to multiply everywhere. Okay. Now that that's multiplied out, let's just go through and collect our like terms. So 2x cubed has nothing to go with. Our x squareds here can add. Our x terms here can add also. And I'm just going to call this V1, or the volume of box 1. Cool. Okay, box 2, similar thing. I don't really need to draw this out again, but we can use our same formula. Volume equals length times width times height. So our volume here, 2 minus 2x. Our width, 3 minus x. And our height, 3 plus x. And same idea, I'm going to start by multiplying my left two brackets. 2 and 3 gives me 6. 2 times negative x is giving me negative 2x. These guys give me negative 6x, so together that's negative 8x. And then I've got plus 2x squared. If you want to switch these around and have your x terms beforehand, you can totally do that. I think I'll just leave these in the order they are until the end. So we're just going to keep on multiplying here. 6 times 3, 18. 6 times x. Negative 8x times 3. Negative 8x times x. 2x squared times 3. And 2x squared times x. Okay. And then our final step here, let's put things in order and collect our like terms. So I've got only this x squared cube, or only this 2x cubed term. For x's, I've got the negative 8 and positive 6, so that's giving me negative 2x squared. For x's, 6x minus 24x. Okay, and this is our V2. So it looks like we finally have an expression that's equivalent. 2x cubed minus 2x squared minus 18x plus 18. So therefore the volumes are equivalent. Okay. Alright, so we got a couple more examples to try. These ones now have fractions, so we're dealing with simplifying rational expressions. So same idea though, we want to start by looking at the left side and the right side separately, seeing what each thing is going to simplify to. Now the only difference with these is you have to remember, for these rational expressions, we need to be able to factor first before we start canceling. So let me just write out this side again. Alright, so we're not allowed to just cancel those x's or divide out those. What we need to do first is factor this. Okay. So our 2x stays how it is, but x squared minus 9, that's a difference of squares. That can factor to x plus 3, x minus 3. And now what we're looking for two things to cancel is that the entire term has to cancel out. So what we can do is cancel out this x minus 3 with this x minus 3. So we're left with 2x plus x plus 3. So that's going to simplify to 3x plus 3. Okay, let's try this side. 3 bracket x plus 1. Well, we still want to expand it out and show that it's equal, but pretty simple, 3x plus 3. So yes, they are equivalent. Okay, now our last one. So just some terminology for you here. When two expressions are equivalent, so say 2x is the same as 4x over 2, This statement, when we write them equal to each other, that's called an identity. So this word we're going to be seeing a lot in the future in our trigonometry unit. So we want to basically prove this identity. We want to prove that these two things are equal or that they're equivalent. And the way we can do that is by simplifying each side separately. So just to make my work a little bit cleaner, I can label left side or right side. So let's start with our left side. X squared minus 2x minus 8 over x squared minus x minus 12. So same as before in this previous question, for us to cancel out a fraction, we need our factors to cancel. So that's going to mean factoring both the top and the bottom part of this. So for the top, we're looking for things that multiply to negative 8 but add to negative 2. So let's go x minus 4 and x plus 2. And our denominator is stuff that multiplies to negative 12 and adds to negative 1. So x minus 4 again, but then x plus 3. Now, this is what we want. We want to have a factor that's the same. If we've got this x minus 4 top and bottom, they can cancel. So this left side will simplify to x plus 2 over x plus 3. Okay, let's try our right side and see what we get there. And just writing it out again. It's the same idea. We want a factor. We're looking for things that'll multiply to negative 6 but add to negative 1. So let's go x minus 3, x plus 2. And then our denominator, that's a really nice difference of squares. X plus 3, x minus 3. Great. So we've got this x minus 3 factor in our numerator and denominator, so it cancels. We're left with x plus 2 over x plus 3. We've showed that both sides are the same, so we've showed that left side equals right side and that they are equivalent. So hopefully you don't have any questions about this material, but if you do, please see me in class or send me an email, and please give these homework questions a shot.